Starlight from distant suns, glow from far-off galaxies, even faint radiations that has traveled for nearly 14 billion years to reach your eyes. But have you ever stopped to wonder, where did the very first light in the entire universe come from? Not the light from our sun, not the light from the Milky Way, but the very first glow that ended the endless blackness of the early cosmos. This is one of the most profound questions in all of astronomy, a puzzle that takes us back to the very dawn of time, to a universe unrecognizable from the one we know today. For decades, scientists have chased this primordial light, using rockets, satellites, and the most powerful telescopes ever built to peel back the layers of cosmic history. Today, we are closer than ever to answering that timeless question: where did the universe's first light begin? To find the first light, we must travel back 13.8 billion years to the moment of the Big Bang. In that first fraction of a second, the universe was unimaginably hot and dense, so hot that no atoms could exist, no particles could settle, and no light could move freely. It was a roiling sea of energy, quarks, electrons, and protons, a chaotic plasma where light particles called photons were trapped. Every time a photon tried to travel, it slammed into a free electron or proton, bouncing around like a ball in a pinball machine, with no escape. The universe was completely opaque, a thick, glowing fog where light could not spread outward. This was not darkness as we know it. It was a universe where light was locked away, unable to shine into the void. For hundreds of thousands of years, this plasma state continued as the universe expanded and cooled, slowly stretching space itself and lowering the temperature bit by bit. At about 380,000 years after the Big Bang, something extraordinary happened. The universe had cooled to roughly 3000 Kelvin, cool enough for electrons and protons to stop flying apart and start bonding together. This process is called recombination, the moment when neutral hydrogen and helium atoms formed across the cosmos. With free electrons now locked inside atoms, photons no longer had anything to scatter off. For the first time in cosmic history, light could travel freely through space. This was the universe's first true light, the first glow that spread outward in all directions, marking the end of the opaque plasma era. Today we call this ancient glow the cosmic microwave background, or CMB. This pivotal discovery was first made accidentally in 1965 by Arno Penzias and Robert Wilson, who detected a persistent, unexplained microwave signal coming from every direction in the sky. Later missions like COBE-WMAP and Planck mapped this light with stunning precision, revealing tiny temperature fluctuations, just a fraction of a degree difference across the entire sky. These minuscule variations are the cosmic fingerprints of the early universe's density irregularities, the very seeds that would grow into stars, galaxies, and galaxy clusters billions of years later. Over billions of years, the expansion of the universe stretched these photons' wavelengths, cooling them from warm, visible, and infrared light to the faint microwave radiation we measure today, just 2.7 degrees above absolute zero. This is the first light, the primordial flash, that began the universe's journey from darkness to illumination. But here is a surprising twist. Even after this first light was released, the universe fell back into darkness. We call this period the Cosmic Dark Ages, a silent, empty era that lasted for nearly 200 million years. There were no stars, no galaxies, no objects shining with light. The universe was filled with neutral hydrogen gas left over from recombination, and this gas acted like a cosmic fog, absorbing any faint light that might have formed. Imagine a universe so dark that no star shines, no galaxy glows, and the only light is the faint cooling hum of the CMB. It was the loneliest era in cosmic history, a time when nothing seemed to change, and the cosmos waited in stillness. But beneath that quiet darkness, a powerful force was at work: gravity. The early universe was not perfectly smooth. Tiny variations in density left over from the Big Bang created areas where gas was slightly more concentrated. These dense regions had stronger gravity, pulling in more gas from surrounding space, growing larger and more massive over millions of years, like snowballs rolling down a cosmic hill. Slowly, these clumps of gas collapsed inward, compressing tighter and hotter. The core of each clump grew denser, its temperature rising to millions of degrees. At a critical breaking point, hydrogen atoms began to fuse together into helium, releasing an enormous burst of energy. In that single, brilliant moment, the first stars ignited. These were not stars like our sun. They were population 3 stars, made purely of hydrogen and helium, with no heavy elements to weigh them down. They were cosmic giants, dozens or even hundreds of times more massive than the sun, burning millions of times brighter, and living only a few million years before exploding. These stars were the universe's first light, the first concentrated sources of light that tore through the cosmic fog. Their intense ultraviolet radiation began to split neutral hydrogen atoms back into electrons and protons, a process called reionization. Slowly, over hundreds of millions of years, these first stars and the galaxies they formed cleared the cosmic fog, making the universe transparent again. This was the cosmic dawn, the moment when light truly conquered darkness and the universe became the bright, star-filled place we see today. For decades, scientists could only theorize about these first stars and the first light of the cosmic dawn. The light from these ancient objects is so far away and has been stretched so much by cosmic expansion that it is invisible to standard telescopes. But then, we launched the James Webb Space Telescope, the most powerful infrared telescope ever built, designed specifically to peer back to this distant era. Webb's infrared vision can detect the stretched light from the earliest galaxies and stars, capturing signals that no other telescope can see. In recent years, Webb has made groundbreaking discoveries, finding galaxies that existed just 330 million years after the Big Bang, pushing back the timeline of cosmic light, and rewriting our understanding of how quickly the first light formed. These discoveries show that the first light did not just come from one single source, but from a wave of star formation that spread across the cosmos, lighting up the dark ages, one stellar fire at a time. The story of the universe's first light is more than just a scientific curiosity. It is the story of our own origins. Every atom in your body, every element on Earth, every star in the sky was forged in the heart of those first-generation stars. The first light did not just illuminate the universe. It seeded it with the building blocks of planet's life and everything we hold dear. It connects us to the very beginning of time, a reminder that we are made of stardust, witnesses to a cosmic story that began with a single glow in the dark. As we continue to study the CMB, observe the first galaxies with Webb, and model the conditions of the early universe, we get closer to fully understanding where that first light began. We are not just studying light. We are studying the birth of the cosmos itself, the moment when darkness ended and creation began. The universe's first light is a testament to the power of cosmic evolution, the quiet force of gravity, and the relentless march of time that turned a hot, opaque plasma into a vast, shining universe filled with wonder. Every time you look at the stars, you are seeing the legacy of that first light. It traveled billions of years, crossed endless galaxies, and survived cosmic storms to reach you. It is a story written in light, a story that began 13.8 billion years ago, and one that we are only just beginning to fully read. The first light of the universe is not just a thing of the past. It is a living part of our present aglow that connects every corner of the cosmos, and a mystery that will continue to inspire us to reach farther, look deeper, and explore the endless wonders of space. Please like, comment, share, and subscribe to the channel.